All right, we should be starting off just in a bit for WorldQuant Office Hours Week 7, right? The penultimate week. I hope everyone is doing fine today. I cut a couple of things on our description of argparse and then talk about web APIs. We're talking about web APIs as a great way to utilize other services to get our tasks done. We'll have a talk about that, and then we'll perhaps start brainstorming project ideas for next week for deploying a web application using Flask and how to deploy it onto a third-party service for you can share with people and have it access on the greater World Wide Web. All right, so I see Anna is here. Welcome, Anna. Someone is asking whether we will be our instructor for Unit 2 as well. It's not 100% sure what's going to happen, whether I will go on to Unit 2 or if I will stick with Unit 1. But for better or for worse, I am the voice behind the Unit 2 videos. So better for worse, in some ways, I'm going to stick around for Unit 2. Okay. Out of curiosity, Anna, if you're comfortable sharing, where are you signing in from? The Netherlands. Okay. I thought you may be signing in from a Spanish-speaking country, since given your last name. Spanish is the only other language I speak besides English. Half Spanish and half Dutch. Okay. There's from Mexico, so a former Spanish holding. One day I do want to visit Spain. Perhaps when this is all over. All right, I see Joseph here. Welcome, Joseph, to Office Hours. Okay, I've got the agenda and web APIs. Agenda. And all this through, we've been working with Git, version control with Git, keeping track of our ever-growing code base. So let's go ahead and kind of do a recap of where we left off. And I felt like last time I would kind of rush towards the end talking about argparse. I don't think I did a proper job in describing what argparse is doing. So I do want to go ahead and take some time to talk about that and wrap up our discussion of argparse. And let's see. I may have lost my connection. So give me a sec. Right, if I did lose my connection, maybe you can't see me. But let me go ahead and go back. I think I have lost my connection. No, I may not have lost my connection. I think you guys can still hear me. Okay, I see Lyndon Smith is here along with Gita. Welcome to Office Hours. Do let me know any additional topics to throw on the board, but I'm going to wrap up my discussion of argparse and then move on to web APIs. So to recap what we did for argparse is we said, you know what, there's probably a better way to define arguments for the command line. Perhaps it'd be very great if we can specify optional arguments very easily in this interface. So I see Naya is here. Welcome, Naya. So the way that argparse works is I create a parser object from this class argument parser. And with that parser argument, I call the add argument method. So I name the argument. I can specify what is the data type of that argument, which is great because remember last time I had to do, they came in as strings and I had to convert them into integers. Not so much now, right? A lot easier, a lot cleaner to get those variables out. And right, the whole thing here is cleaner code is readable code. Readable code is more maintainable code, right? Let's help out our future selves when we have to maintain our code. And I give a little help message. And this help message can be invoked in the command line. So if I go here, if I go to my command line and I type in cd, let's see, what did I call that? Type in ls Let's cd data course, change my directory to data course, type in ls, and I see prescription drug analysis, so let me cd into that directory. Type in ls, I see my file, drug data analysis, so Python drug data analysis -- help. So now I'm able to invoke the help menu for my command line program. Just like we saw, I think, last week or earlier this week, working with command line, how to look up the documentation to run a command, run a program. For example, if I want to know what ls does, ls -- help, I get an information about what the ls command does. cd -- help, spelling counts, right? Get information on what cd does. So now with my command line program that I wrote, I can look up the help menu. And it says, right, where it got that information was from this description here, from this string here. So then I know, oh, okay, I provided 2 positional arguments, z-score cutoff and raw score cutoff, a raw count cutoff. A little description of what it does. All right. So what I want to do instead is that this script, I have to provide the cutoff, the z-score cutoff and the raw score cutoff every time I run the script. It'd be very nice if there were an optional argument to use instead. In other words, I don't have to specify both arguments. If I don't, it defaults to a certain value. So let's see how we would do that in our args parse. So let's go ahead in here, and what we are going to do is we're going to call add argument, and we are going to do -- rename this to be -- hold on, let me look up something really quickly. -- I type as integer, I give a help message, and what I'm going to do is I'm going to specify a default value. So I can say default equals, and I think I'm going to choose a default value of, let's say 3. I'm just going to break this down into multiple lines. It's a little easier to read. Let's go ahead and same thing here. I can say default and say default to, I think, let's say 50, right? I could choose whatever I want. And then I can go ahead and just separate that out. So I have a default value for these arguments. And I'm printing out what comes out, printing out what this args is just to visualize it. And now I'm going to go back to the command line and run my script. Run my script, and I get an error, syntax error. So let me go ahead and investigate. Oh, forgot a comma right there. A silly mistake. Go back to the command line. Let's run that script again. Get a name error, so sys is not defined. Well, I didn't import sys. I actually don't need this anymore. I'll just erase that. And I still get a name error, probably because I didn't save. And let's try that now. Let's go ahead and try that now. Third time the charm. I still get a name error. Okay. Yeah, because I forgot to comment this stuff out. Okay, let's see. Do I have everything? Let me just double check. I'm actually not going to run the script just for the meantime. I just want to see how it works. So what's going to happen is that we're adding these arguments to this parser object. Then we will call the parse args method, and what gets returned is called a namespace. It's a namespace that's going to store the parameters, the arguments that were passed when I invoke the script. So I go back here. Let's try that. And it ran. Notice it ran. And since I didn't specify what should be the raw count cutoff or the z-score cutoff, it has the default values. There it is. So now if I go here, and I want to access the individual values, its args, and z-score cutoff. So I can have a little print message here. I can say f string, and I can say my z-score cutoff is and print out my raw count cutoff is args raw count cut off. I'll go ahead and save that there. So what I'm going to show you here is that this object has these arguments in it. And the way I access it, it's sort of like an object with the attributes. So this here is a namespace. You can think of it as holding the values for my program. So if I go back here, let me just clear the board. Control L. So I print out the args object. It's a namespace. It tells me what the values of z-score cutoff and raw count cutoff, and I print them out, and there they are, 3 and 50. These are the default values. So what if I want to specify something that is not the default? Well, I need to be specific, just like in Python. If I want to have a function and I want to use something that is not the default, I'm going to be explicit. So I say z-score cutoff equal, let's see, 5. Yeah, 5. And run that there. And notice how the z-score cutoff, since I specified what it should be, it was 5 instead of the default of 3. All right, I see Paulo is here. Welcome, Paulo. I see Simon is here. Welcome, Simon. And welcome, Timur. Welcome to Office Hours. So now I specified a different z-score cutoff that is not the default. If I want to specify a different raw count cutoff, well, I'll just do -- raw count cutoff and set that equal to, I don't know, 100. So I run that, and sure enough, I see the values have changed. So notice what I've done. I've gone to the script. I created this namespace object with the values that are passed when someone runs the script, and it has certain default values. And I should make use of them in my code. So let's actually do that. I'm going to uncomment these lines right here. I wasn't actually running anything. And I say args.z-score cutoff. Args.raw-score cutoff. All right, I see Soon Johnson is here. Welcome, Soon Johnson, to Office Hours. So now I'm going to go ahead and save this. And I go back to the command line. And I can run my script. It's still printing things out. And I get an attribute error because I probably have a typo, right? Let's see. I called it z-score cut off with 2 T's with 1 F. Let's see what my mistake is. Z-score cut. Only 1 T. I probably was inconsistent in my spelling, unfortunately, right? Just fix that. I don't need to print this stuff anymore. That was just for practice. Comment that out. And I go back here, clear the board, run it. It should work out now. Yeah, it worked out. I think so. Look, we call head and drug data analysis. Oh, sorry. Call the head of practice is flagged. And looks like there was no records that had that criteria. There was no records that had a raw count of 100 and a z-score cutoff of 5. So perhaps I should drop my raw count cutoff to 20. And then I can call head of practice is flagged. And it looks like I had 2 records that meet that criteria. It looks like their z-score is greater than 5 and the raw count is greater than what I specified, which I forgot was 20. Okay, any questions people have regarding argparse? I'm just going to go ahead and erase this code right there. Let me know if there's any follow-ups with what I have here. I still got to commit my changes, of course. We saw that workflow. We create a branch, add the feature, commit those changes, and then merge that branch into the master branch. All right, let's go ahead and commit those changes. Control L, clear the board. I like to say git status. I always run git status to see what has happened. All right, I do see a question here in the chat, so I will take a look at that just soon. So I see that that file has been modified. I do git diff, show me the difference. So there is the difference. This solid block here is saying that there is some white space right there. These are white space characters that it's just letting me know that, hey, there's white space characters there. You may want to remove them. Not that they won't affect our code, of course, but just for style reasons, we probably don't want those white space there. So I'll just go ahead and highlight that white space and remove it. Hit save. Go back here and do git diff, and I see where I've added my code. And these changes were all about adding support for args parse. So I'm going to do git status. I'm going to do git add. I'm going to add the file, drug data analysis, add it to the staging area. Then I'm ready to commit and add that to history. So I'm going to add git commit, and my commit message should use present tense and should follow the following phrase. With this change, what happens next? With this change, we add support, let's say command line support with args parse. Hit enter, and I do git log, and you don't have to do this every time, but I'm just doing it for illustrative purposes. I see my commit message right there. I'm going to take a look at the chat here. In the first argument of add argument, first argument of the add argument, the name of the variable. If so, is the dash dash not include the name? The dash dash is not included in the name that is correct. And the reason why is this is how in the command line, the way you specify optional arguments is dash dash. That is the style of working in the command line. The way you specify optional arguments is through dash dash. And so it says, okay, so it knows that the name of the variable would be the part that follows the dash dash. Yep. And now we have a script that we can run the command line, which is pretty powerful, because if we have a script that runs the command line, you can imagine that we can automate this process. We can schedule this process. It is a script that can be programmatically run. So I'm going to do git checkout master because I want to merge this change to master. So git checkout master, and git merge the name of the branch, which is called CIL support, which stands for command line interface. So git merge, and maybe I messed up. Let's do git branch, master, git log. Let's see, git checkout. Let me do git branch to see my branches. May have messed something up. Git checkout args parse support. Let's see, git checkout args parse support, arg parse, and git log. I see that there. Git checkout master, and git merge, and what I call that? I call that arg parse support. I think I misspelled it. Arg parse support. And there we go. I made my change, and I do git log just to convince myself that sure indeed in my master branch I have this latest commit. All right, let me know if there's any follow-ups. I'm going to wrap things up with a discussion of remotes and then we'll move on to web APIs. So what we've done so far is this project only exists on our server in your personal account if you've been following along at home. It's not accessible to anyone else. So it's not going to work well if we were to work on this project all together. So instead, what we got to do is we got to take our local repository and we got to push it. We got to push it to a remote repository. So here am I. I can push this to a remote repository, which will enable, and depending what I can do, is I can have other people have access to this remote repository. And you can think of the remote repository as holding the single source of truth for the project. So someone else can take this and can pull in the project and submit their changes. And what we need to have access to is we need to have access to a service that will allow us to host our code. And one such popular service is GitHub. GitHub is a popular service for hosting repositories. You can create a GitHub account. It's free. You can hit new. You can create a new repository. And so, for example, I would say example project. That's what I call the repository. And I will make it public. And I would just, there's some things about creating licenses and get ignored. We can just ignore that for the meantime. Create repository. And what it has here is a set of instructions on to push an existing repository from the command line. It's telling us how to do it. Now, I'm not going to follow through with it only because I realize that this example here, I don't want to share it publicly because it has the solutions in a way for the mini project. So I'm not going to push it to GitHub, unfortunately. But you can imagine if we were working on another project, which we will get started on soon, that we can share publicly, that we can go ahead and push that project publicly. And then other people like you can merge in the changes, clone that repo, and even suggest your own changes. And that's what we're going to build up to. So unfortunately, I'm not going to follow these last minute steps to push the project to be hosted on GitHub because I don't want, because this code has the solutions, right, for the mini project in a way. So we won't be doing that. But let me know if any follow-ups. If not, I would transition into talking about web APIs. Because then when we know about web APIs, then we can go ahead and talk about building some sort of web application. Okay, let's talk about web APIs. And the way that the web works, a very simplified way the web works, is that here we are. I'm going to draw a picture of a person. And there is a server on the web. And let's say I want content from this server. I want some data from this server. And the way the web works is a client-server paradigm. The client, you can think of it as you, is going to submit what is called a request. It says, hey server, give me some data that I want and that I need. The server will take your request, and depending on the nature of your request, it can either deny it, or it can give you some content back. We send a request, it is valid, so we'll let the server decide whether it's valid or not. That's sort of not up to our choice. And then the server sends us back what is called a response. And the response contains the data that we had asked for. And this is how basically the web works. Of course, a lot more complicated, but this client-server paradigm. And we can view our web browser as being a client. So for example, if I go to google.com, my web browser is the client, and I'm going to type in Python. I'm going to search for the word Python. I'm going to hit enter, And what is essentially happening when I hit Python is that my web browser, right, my web browser, is making a request to Google. And what I'm sending in the request is telling Google, hey, give me the data associated with searching the word Python in your search engine. So I've sent them my request. I sent them looking for Python. Google receives the request. It says, okay, I'm going to handle your request. And it sends me back an HTML file. It sends me back a HTML file that my browser takes and renders for me in a very nice form. I can say view page source, and this will vary between your browser. And here is the source, the HTML that the server sent back to me. Of course, it's quite ugly, right? But that's why we have a browser that renders this. And that's how it works. That's how generally it works. So the reason why this is of interest for me, or of interest for us, is because maybe we want to build an application. Maybe we want to build an application. And the way we can think about it is we want to have our users right here. Here is our users. We have our application right here. And maybe a very simple application is a user visits our site. And then maybe we take their IP address. We take the IP address in the request field, and we could rely on a third-party service that takes that IP address and figures out where they are located. IP addresses, there is a pattern to them. So with an IP address, you can figure out what country, what city someone is based upon. Now, of course, there are ways around it. There's VPNs and proxies, but let's not get overly complicated. The whole thing here is that with an IP address, you can get a location. Whether that's actually where they are, that's a whole other story. Right? There's ways around it and ways to, combat it, whatnot. All right, we're not learning cybersecurity and whatnot. So we can rely on a third-party service where we make a request and sends us back data. So send the IP address and get back location data. And then with that location data, what we could do next is we can go ahead and rely on another third-party service. Maybe one that gets me the weather with a given location. So here is location. Ooh, really messed up. Right on that location. And get back weather. And then once I get the weather, maybe I visualize the weather. Maybe give them a weather forecast. Take that raw weather data and generate a plot. Right, this is the plot of the weather. And then maybe I send back to them that plot. So a lot of moving pieces here. There is a person making the request. I fetch with their IP address, fetch where they are, take that location information, get the weather, generate a visualization, and send that visualization back to my user. And the way this would work is this requires, if I were to list all the things it requires to do this project or do a similar project, is we have to learn how to use Flask, which is a Python web framework. I've been talking about it a lot throughout the program, so we're finally going to get to it. We're going to use Git. We learn how to use Git, so we'll keep on using Git. We will learn how to make web requests. And finally, perhaps some visualization, right? Some visualization. Someone asking, not Django? The answer is not Django. There are two competing web frameworks in Python. There are a couple other ones, but the two main ones are Flask and Django. Flask is a lot easier to get started with. It's called a micro web framework because it doesn't include everything out of the box, but it's a lot easier to get things going. Django does require more setup, And because it requires more setup, it's has a sharper learning curve, has a steeper learning curve. So we're going to use Flask. In fact, our application website from Worldcon is built upon Flask. So just an endorsement of Flask in such a way. So we're going to use Flask, Git, web requests, and visualization. So let's learn about web requests. And right here I have a GitHub repo. It's not mine. It's someone created that I really like and I like to share. That shows a list of public APIs. API stands for Application Program Interface. It's just a fancy way of saying how to interact with a web application, how to interact with the program. This is important because I can look at these as all different, they've broken down different APIs, and there's some interesting stuff. Like, for example, let's see weather. Let's see. Weather's, I don't know. Let me think. Let's see calendar. Let's see what this is saying. Catholic literature calendar. Look up a name for a name. Check name day calendars. Interesting. Holidays. Let's see. Let's actually look at. Let's look at IP address. Let's take a look at that. Another simple IP address. This might be of interest. I'm going to right click there. Take a look at this one too. And what this says here is the quickest and easiest. Let's see. So I think this is a service that can give me the information of an IP address. Let's see this here. What does this do? This here, if I look at the usage, this appears to give me the IP address. So I can use this to figure out the IP address of our server. Okay, let's see. Okay, so let's try this out. I'm going to copy this. Let's go into a notebook. I haven't done notebooks in a while, so I'll do that. New Python 3. I see Gita is saying, and I see Timur. I'll get back to you, Timur, just in a bit. The first website, from what I've noticed, requires a login. Is it still a public API? So public API is still a login. Can provide a login. However, that login, it might be free. So we'll talk about authentication as well. So I'm going to import a Python package called requests. And requests is a Python package that allows me to do web requests. I'm going to run that there. And I'm going to say response is equal to requests.get google.com. And I get, I've got to give the full https://google.com. And I get a response object. And what a response object is what I got back from the server. So I can say status code. Remember those status codes that you might encounter when you go into a website. You go onto a website, for example, if I go onto GitHub and I do GitHub gibberish. 404 is called a status code. It tells me the status of my request. 200 means it was a successful request. 300, right, 200 means success. 200 success. A 300 status code means a redirect. A 400 status code means it was a client error. meaning it was probably my fault. And 500 is a server error. And there are more than just, there's several 400 codes, there's several 500 codes. They mean specific things, but they're generally grouped in these 4 categories: success, redirect, client error, server error. The client, one of those client ones is 404, meaning page not found. There is, I think it's called 403 error. Every time you see a 403, that means you're forbidden. For example, if you go onto our application website and you log in with the wrong credentials, then it gives you a 403 because you are forbidden to access that content. So these status codes will give me an idea of whether my request, the nature of my request. Was it successful? Was it a redirect? Was it a client error? Was it a server error? A server error means that something broke on the server end. It could be my fault. It could be the server's fault, but basically something broke down on the server's end. It could be some piece of code that that caused the problem, the program to crash. And someone is asking whether Flask is a model view controller, and I think Flask should be considered model view controller. And so we'll look at the syntax more on it next week, so we'll get a better appreciation of it. All right, Gita, the first website, from what I've noticed, requires a login. Is it still a public API? Yeah, I would call logins still public APIs, because anyone from the public can sign up for the service and get what are called a token to access that service. So we'll talk a little more later about authentications. So I got my response. What exactly is in this? If I type in content, there's an attribute called content of the response. If I look at it, it's the HTML. It's the HTML that the server sent back to me. So the server sent me HTML. Which makes sense, because when I go to google.com, I want it to give me HTML for my browser to render. Any questions about this example of using requests? We're going to go ahead and play around with our web API that we found, but any questions so far? Okay. Do let me know. I'll pay attention to the chat. So now let's make a request. Let's do response. I'll do requests.get. And there is this service I'm going to use. I'm going to run that there. I'm going to say response, right, .status code. So response status code. 200. It was successful. Now let's do response content. Let's see what it gave us back. And it looks like HTML. Let me go ahead and look at this service once again. Did I use the right one? I may not have used the right one. I wanted to use IPF. Let's see, that's the one I did want to use. Oh, I used the wrong URL. So let me go fix that. Run that. Status code 200. Let's look at the content. And notice I have a string that has my IP address. So this is the IP address of my pod. So then what I can do next, I can go ahead and say, well, where is my, where is this IP address located? Right? We talked about how IP address has information about where a server is located, where we're located. So let's see if we can go here and look to find if there's any service we can use to give us the location for a given IP address. So maybe another simple, let me look at this one here. This might be of importance. So this might be of importance. This might be of use. Let me type in geo. Maybe there's some other stuff. Geocoding, geolocation. IP geolocation with chat ops integration. IP geolocation and currency conversion. That might be of use. Find geological geolocation with IP address. Let's look at there. This IP info, and let's see how this works. If I go into documentation, well, this is the one I've been looking at for a while. Let's try it out. I'm not sure why I'm so hesitant to not try it out. So it looks like the way it works is I'm going to make a request to this endpoint there. In other words, if I go, let me just copy this and put in my browser. I'm going to do slash the IP address. Copy that right there. And notice how I got information about where this server is located. Right, so it looks like it's in Virginia Beach in the state of Virginia in the US. Local time, coordinates, postal code, right? Oh, I even gives me information about who is hosting that service. It's Amazon. So this makes sense because we use Amazon Web Services to host our Jupyter Hub. So now what I can do is I can use, notice I did this in my browser, right? I did this in my browser. However, I want to be able to do this programmatically. I want to be able to write a program that takes an IP address and gets this information. So let's see how we would do it in Python using the requests package. So I call, I say response is equal to requests.get. Have it right there. I run that. Let's do response.status code 200 response.content. And what I get is a JSON. I get a JSON. And this is great because if I have a JSON, I can call the JSON method of the response object. And what this will do, this here will convert that JSON string into a Python object. So I run that, I type in data, let's check that out, and I have a Python dictionary with the fields with information that maps key value pairs, the IP address, the host name, the city, the region, the location. I am good to go, right? Any questions people have? I'm thirsty today. Okay. So now we can begin to write some code to do something interesting. I know how to get the IP address of my computer. I know how to use that to get information about where I'm located. And what I can do next is I can use this location data to get the weather. So how about that? I'm going to just close a couple of tabs here. And let's see if there's anything about maybe weather. All right, so I look at here and I see a couple of weather APIs. And notice some of these say API key, and some say no. Well, these services, right, they're not free, right? Well, how about this? These services cost money to maintain, right? Someone has to pay the money to maintain a service to get me the information about an IP address. Someone is maintaining a service that will tell me the weather, right? Someone is paying for that. And I was able to access it for free. Well, because some of the business model is what it does, it will allow me to have a free tier. It's like you sign up for free. Free tier where it says lets you access the resource. But you can imagine what they're doing is they are keeping track of how many times I make use of the service. So maybe if I were to rely on a service too much, it will shut me down. Some services are free, but they ask you to sign up. They say sign up with us, right? Because they want to know your email address and maybe some information. And then once you sign up for them, then in your account, you can look up what is called an API key. Think of it as a password. So that when you use the service, you provide the API key. And this way it says, okay, you've been authenticated. I will let you use my service and I will keep track of how many times you use the service. Because maybe I have a free tier. I might say you can use this service 100 times a day. But of course, if you want to use it more than 100 times, you got to give us some money. So let's see if we can use a service that requires no authentication just to get things going, just a lot easier to get something going. And I see this one called Meteorologic Institute. Let's see, I'm not sure what language this is in. That's Norway? Sorry if I am completely wrong here. Let's see. I think this is a Norwegian service. Norway flag. Yes, I think I'm right. Yeah, I think I'm right. I think that appears to be a flag. Okay. Yeah. Americans do know geography. Okay. So I take a look at this and maybe I can use this service for getting weather. Let me look up the documentation. For these services, you may want to look up at documentation because it oftentimes will tell you how to use this service. And then let's see. And general forecast JSON format. Let me go back. How to, right? Why not? How to. Let's look at that. And look at that right there. It's a little hard to read, so I'm going to blow this up. So it's telling me how I can get information. So notice I'm going to go ahead and copy this right there. And if I put it in my web browser, I get a JSON. And I'm going to paste it right there. So this gives me the weather for 60 latitude and 11 longitude. And notice, I'm going to notice this URL. I'm going to break it down, this URL, into two pieces. There is this portion right here. And notice there's a portion that starts with a question mark. The portion that follows a question mark is called the query string. We can give data. When we make a request there might be some information that we want to be in the request. For example, it's like asking, I'm at a restaurant and I ask the server, give me my dinner and this is my dinner. This is what I want from the menu. I make a request and I say, give me the meal number 55, whatever meal 55 is, right? Give me the steak frites. I'm craving steak frites today. That is the query string. So when I make a web request, there might be some data attached to that request. For example, here I want the weather, but what location? Latitude, longitude. That information goes after this question mark. It's called the query string. And notice how the query string is, how it's displayed, how it's arranged, how it's set up. It's a key equal a value. Ampersand, a key equal to some value. So notice what follows the question mark is our query string that arranges data in key value pairs. So what I can do is I can say URL, and I can say curly braces. Remember how we can use a format string? And I can say lat equals 36, lon equals -76. This will create my URL. So I'll run that there, and I get a syntax error. And let's see, the reason for, I forgot to put lat and lon right there. And I will print out my URL. So notice how I create a URL, and I can right click that with the values of latitude, longitude using a format string. Right click that, open link in new tab. And here is the weather for where we are, where our server is. It's kind of messy, a lot of information out there. But here is our weather data. Let me know if there are any questions. Okay, I'm going to go ahead and move on. So now what we can do is we're going to use, let's use requests. So we're going to say data, I'm going to say response equal to request.get URL and response JSON. So here we're getting the weather data. Now, a better way to go about doing this is what we're going to do is we're going to separate out this URL. We're going to have what is called the endpoint. And what we're going to do is we're going to create a dictionary called params. And the reason why we are creating a dictionary is because you can think of the part that follows this part here. It's basically data in key value pairs. So instead of us manually formatting this URL string, we can let requests handle the formatting for us. So a better way to do this is to break our URL to the endpoint, so everything but the query string. Then we will create a dictionary that maps those keywords with the value lon and lon. And then when we say get, we pass the URL, the base URL, and then we use a keyword argument params. And here we specify those key value pairs that should be in our query string. So it's going to format this URL for us. So let's try that out. I run that. It seems to work. response.url, and here is the URL it created. So notice it did the formatting for us automatically. So this is the better approach. When we're working with query strings, information we pass in the request, by the way, this is called a GET request, a GET, all caps, a GET request, because the data we pass it is in the URL. So this is the preferred way to go about doing this. So now, rather quickly, notice how in just about less than an hour, we were able to quickly write up Python code to get our IP address, to get where we're located based upon our IP address, and get the weather based upon our location. So you can imagine now what I can do is I can take all this code and put it into a Python script. I can put it into Python script that I run and tells me the weather of where my server is located. So let's go ahead and do that. And we think of our process here is there's really three processes: get our IP address, get our location, get our weather. So maybe we should put those all in three functions. Use three functions for this process. And that's what we're gonna go ahead and do next. Okay, so I can say define a function. I'm going to call this retrieve IP address. This function doesn't accept anything. There's no arguments to accept, and I will go ahead and let's see, where is that code to get the IP address? Right there. And then I return response.text. I'll put a little message, a document string, say return IP address of our computer. Create another function, and I'll call that get geolocation. Document string, return geolocation using geolocation of an IP address. And the argument accepts is a string with the IP address. And what we do, let's go back here. And where was that code for getting the geolocation? Right there. So response, and I will have a format string because I don't want to hard code that. And I will put that right there. IP address, and I return response.json. Returns get back a JSON, so I can return that JSON. And now in that JSON, if I look at it, I can get the lat, and let's see, where is a lat? Okay, it's in locate. I see, it's in a string called lock. So what I can do is perhaps I'm not quite done yet there. Maybe what I can do instead, and I will practice here. Let me just run this. Run. And what I can do is with data, I can say, give me lock, and then I can say split on a comma to get two parts, and then I can convert that into integer. So I can say for chord in that, cast that into an integer. And let's see, literal with base 10. Oh, I'm not going to convert to an integer. What I'm talking about, I want to convert to a float. Okay, there we go. That's my coordinates. So I copy that. And let's see, I can call this data. Chords, return chords. And then finally, I have a function called getWeather that accepts my chords. It says return weather data for a given set of coordinates. And then let me copy and paste what I had. Let's see. Chords is a list, so I say chords 0 and lon chords 1. I think that's how it works. I think it's first is my latitude followed by longitude, right? Because the U.S. is in the Western Hemisphere, so it has a negative value. And let's see. There we go. I have my 3 functions. And then I can say, I can have a main function. What that main function does, gets the IP address. I call that retrieve IP address. I can say chords is equal to get geolocation with IP address. And then weather data equals get weather chords, and then maybe return that weather data. Then I can call my function. Get a name error. It's because I probably have a typo, right? Exactly. Typos. And then there's my weather data. So there we go. Notice quick 3 functions working together. Package it all together to main function. I get the weather data. Of course, this is get a bit messy, so maybe later I can figure out how to pull out specific fields here so I have a better display message instead of just here is the raw data. Right? This service gives me a lot of information, so I can perhaps figure out what I want from it and just take that. So I of course improve on this process here. But this should give you a taste of working with web APIs. So you can imagine now with this we can build upon a project that we outlined here using Flask. So any questions people have before I wrap it up for today's office hours, for the week's office hours? I will post this code on the shared drive. I'll probably do this later today. I will post this office hours code on the shared drive for you to have access to. Any last things people want to bring up before we convene for this week's office hours? Go for it, Timur. Go for your question. Thank you, Paulo, for the wishes. Timur, let me know your question. I missed a few office hours. What is the best way? I missed a few office hours. What is the best way to catch them up? Take a look at the. Keep in mind that we have a playlist of the office hours. So I would encourage you to look at the playlist. If you go to video links, we have the playlist. Will we decide a project next Monday? Yeah, I think next Monday we can talk about. My default is to do what I described here, this project, and which is kind of generic. But the whole point here is that if we work on it together, then you can take what we did and make it your own. What is the best place to get Flask documentation and examples? I can show you. There is a guy named Miguel. Green Flask. There is. I like this. This here. I think it's a good information on Flask. All right. So Timur, take a look at the playlist. I can post it here, and take a look at the past videos for you to catch up on. And we have thumbnails, so you know what the topic is. So maybe it is not of interest. You can just skip it. Many thanks for the answer. I saw the links. I mean, how office hours per day? Let's see. I missed the best way to catch them up. Keep in mind that office hours occur. If you're looking for the times, we have them right there. I'm not sure if that's what it's asking for. Many thanks. Should I have 8 hours missing? What is the most important for the next week? For the next, we're kind of done talking about mini project stuff. How office hours per day? So we have 4 office hours per week: Monday, Tuesday, Wednesday, Thursday. But there's Unit 2 office hours that happened. So in total, there's 8 hours of office hours for the program, but 4 only for Unit 1, 4 for Unit 2. Let me know if that answered your question. I can take a look at the Jupyter Hub for the times. This should be localized. I think this should localized for your specific time zone. All right, I have to take off. Timur, I hope that answered your question. With that said, take care, guys, and have a good rest of your week, your good rest of your day, and see you on Monday.